The first type, that is liquid or fluid at rest. The interesting example of the fluid at the rest, it is surface tension. Surface tension, it is the interesting example of fluid at rest. Then we see here what is the surface tension. What is the concept of surface tension? See, suppose the fluid, it is at rest. Now here this is the fluid, this is the liquid, it is water. Suppose for example, we can take any example of fluid. Mercury is also fluid, kerosene also fluid. Here we take the example of water here. Now the spider, suppose the spider walks on this water. This is the example of surface tension. There is the example of surface tension. Now suppose there are the raindrops. These raindrops are in spherical shape. Suppose these are the raindrops and these are in the spherical shape due to surface tension. Now suppose there are a soap bubble. These soap bubbles are also in spherical shape. This is due to surface tension. These are the various examples of surface tension. Now today we see the surface tension and the properties of surface tension. Before studying the surface tension, we see some concept. There is the force, or there is the types of force acting here, and which are intermolecular forces. This is the one of the real force. There are different types of forces, you know. Gravitational force, electrostatic force, magnetic force, and this intermolecular force. These intermolecular forces are short range forces. These intermolecular forces are short range forces. The range is about 10⁻⁻⁷. Now see the intermolecular forces. What is the intermolecular forces here? Now suppose these are the molecules of the fluid, gases, etc. Now see, suppose these are the two molecules. There is a force of attraction. Between the two molecules. The force is called as intermolecular force. There are two types of intermolecular force. The first type, it is called as cohesive force. And the another type, it is adhesive force. See, intermolecular forces are of two types, cohesive force and adhesive force. Then what is the cohesive force? The cohesive force, suppose we take the container and the liquid inside the container. Suppose container filled with water. Then these are the different types of molecule, or these are the liquid molecules. Now in this case, the force of attraction between two molecules of the same material. Here the liquid molecule, there is a force of attraction between two liquid molecule, and this force, it is called as cohesive force. That is, we can say that, what is the cohesive force? The force of attraction between two molecules of the same substance, it is called as cohesive force. Then adhesive force, suppose this is the molecule of water and this is the molecule of glass. Now there is a force of attraction between two molecules and it is called as adhesive force. Thus we can say that the force of attraction between the two molecules of different substance, it is called as adhesive force. These are the intermolecular forces. Now we see, suppose there is a various concept, range of intermolecular force, molecular force. We see the different concept here, range of intermolecular force, then range of intermolecular forces, See here, what is the range of intermolecular forces? It is denoted by R. Now suppose the molecule, it is at the center. Now we know the intermolecular forces are of the short range forces. Now this is the maximum distance up to which the intermolecular forces are effective. It is called as range of intermolecular forces. See here, the distance, the maximum distance where the intermolecular forces are effective, it is called as range of intermolecular forces. What is the range of intermolecular forces? It is the maximum distance for which the intermolecular forces are effective. It is called as range of intermolecular forces. Now, suppose we can say that is the sphere of influence. Sphere of influence. See here, sphere of influence. In this case, suppose this is the molecule at the center. Now, this is R is the radius or R is the range of intermolecular forces. R is the range of intermolecular forces. Now, suppose we consider the molecule, it is at center, and if we draw the sphere considering R is the range of intermolecular forces, and it is called as sphere of influence. What is the sphere of influence? The molecule of the liquid fluid, it is at the center, and radius equal to range of these intermolecular forces, it is called as sphere of influence. Then we consider surface film. Here we consider a container consisting liquid, then free surface of liquid. The upper surface, this XY, it is called as free surface or free surface of fluid or free surface of liquid. Now, the X dash, Y dash, the thickness XX dash, YY dash, it is called as surface film, surface film, surface film. Now we see the molecular theory on the basis of these intermolecular forces. Molecular theory, surface tension on the basis of molecular theory. Surface tension on the basis of surface tension on the basis of molecular theory. See here, we consider the liquid at rest. Now this is xy, it is free surface, xx dash, yy dash, it is surface film. Now we consider the molecule here. Molecule A. Now this is the sphere of influence. This is the sphere of influence. This molecule, it is called as molecule A and it is called as sphere of influence. It is well inside the liquid. Now another molecule B, it is just below the free surface. It is just below the free surface. This is the molecule B, sphere of influence of this molecule B. It is just below this liquid surface, free surface, that is in the surface film. Now the third molecule, the half part of the molecule, it is in the above, it is in the air, and half part it is in the liquid. It is in the liquid. This is molecule C. This is molecule C. Here we study the surface tension on the basis of molecular theory. Now see here, we consist of the water containing a container. This is surface, free surface, xx dash, yy dash, it is surface film. Consider the three molecules. Molecule A, molecule B and molecule C. See the molecule A, B, C which are in this liquid. Molecule A. See here, molecule A, it is well inside the liquid. Now in this case, this is well inside the liquid. See here, these are the water or liquid. This is also liquid. Suppose we consider water. This is water. This is water. Then there is a same substance, molecules of the same substance. Therefore, there is a cohesive force, and the net cohesive force acting on molecule A. The net cohesive force acting on molecule A. See here, there is a net cohesive force. The liquid molecule, it is inside the liquid. The net cohesive force acting on this molecule A, it is 0. There is no force acting. The force is equal and opposite. The net cohesive force, it is 0. And this molecule remains inside the liquid. It remains inside the liquid. Now in case of molecule B. In case of molecule B, what happens in case of molecule B? In case of molecule B, see again it is just below the liquid surface, and this is again liquid. There is again liquid. There is net cohesive force again here. Some part of this sphere, it is in the air, but these are the smaller number. The air molecules are in the smaller number and liquid molecules are in the larger number. In case of molecule B, the number of air molecules are smaller in number, as compared to liquid molecule. Now in this case number of liquid molecules are larger, hence net cohesive force is greater. And in this case the net cohesive force, the effect of this, the liquid molecule B pulled inside the liquid. It is pulled inside the liquid. This effect gives this pull inside the liquid. Pulled inside the liquid. Now in case of C molecule, see here, molecule C, this is the sphere of influence C, half part is in the liquid, half part is in the air. Now there are air molecules. We know the density of this air, it is smaller, hence again there is a net cohesive force. It is stronger, and it also, C molecule is also pulled inside the liquid. It is also pulled inside the liquid. See, from this consideration, we can say there are number of molecules on the top of this surface. Each molecule tries pull inside the liquid. Now hence, the upper surface, the number of molecules at the upper surface decreases, and this upper surface, this free surface, it behaves like a elastic membrane, and it is due to, or it is called as surface tension. See here, what is the surface tension? Each molecule want to go in the liquid at the bottom. Now the number of molecules at the free surface, it is decreases, and the free surface behaves like a elastic membrane. It is called as surface tension. Here we see the surface tension on the basis of molecular theory. Now we see the definition of surface tension, surface energy, and etc. The surface tension. Surface tension, it is denoted by T. Now suppose we consider the free surface, and this is the surface tension. These are the forces at right angle. Thus we can say that surface tension, it is defined as it is the force per unit length joining, or it is the imaginary lines, the force acting on this imaginary line. The surface tension, it is force per unit length. Now SI unit of surface tension. Surface tension. See, the SI unit of force, it is Newton. SI unit of length, it is meter. Then SI unit of surface tension, it is Newton meter, or we can write it is Newton meter inverse. This is the SI unit of surface tension. Then dimension. We know T is equal to force upon length. Dimension of force is L1 M1 T minus 2 divided by L. Then here we get L0 M1 T minus 2. It is the dimension of surface tension. We see the next concept, surface energy. Surface energy. What is the surface energy? See, we see the molecular theory here and the upper free surface. Each molecule wants to go inside the liquid. Now the upper surface, free surface, it is behaves like an elastic membrane. There is a surface tension. But for equilibrium, the some molecules are bring in the upward or in the free surface and the work is done. The work is done. This work done stored in the form of potential energy. This work done stored in the form of potential energy, and this potential energy, it is called as surface energy. Surface energy. And the surface energy, it is a energy. Therefore, SI unit of surface tension, surface energy. SI unit of surface energy, it is joule. It is joule. SI unit of surface energy is joule. Now there is another relation. See here, suppose surface tension T is equal to dW divided by dA. Then again we can say SI unit of surface tension, work is in the form of joule, and now area is in the meter square. This is also unit of surface tension, joule per meter square. This is all about surface energy.